Assalamualaikum. My name is Amirul Aiman bin Muhammad Aslan. I'm from DEM 3A. My metric card number is 14 DEM 19F 1039. Okay, today I'm going to talk about objective for the Lab 2 report, force, mass and acceleration. Okay, first we talk about objective. Okay, the objective of this experiment is to verify the validity of Newton's second law, which states that the net force acting on an object is directly proportional to its acceleration. Okay, the formula is m1g m1 plus m2 and a plus f was derived on the base of the law. Okay, therefore we can consider the formula to be a prediction of the second law. Okay, in this experiment we will seek to verify this specific prediction and thereby provide evidence for the validity of the second law. Okay, next we're going to talk about the theory. Okay, according to Newton's second law, the resultant force on an object is directly proportional to the mass of the object and the acceleration that the object undergoes mathematically. This is expressed as F_ma, where in SI unit F is in Newton and m is in kilogram and is in milli per second. Alright, that's all. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzuddin bin Muhammad Rozi from DEM 3A. Number register is 14 DEM 90F 1037. Today I want to talk about force, mass and acceleration for subject engineering mechanics. The lecturer name is Encik Syarul bin Mustafa. Okay, I will discuss about introduction, equipment and safety. Okay, first of all, the introduction. Newton's first law of motion pertains of the behavior of object for which all of exit force are not balanced. The second law states that the acceleration of an object is depend upon two variables: the net force acting upon the object and the mass of the object. The acceleration of the object depend directly upon a net force acting upon the object and inversely upon the mass of the object. As the forcing acting upon our object is increased, the accelerate of the object is increased. Of the mass of an object is increased, the acceleration of the object is decreased. According to Newton's second law, acceleration is produced when a force acts on the mass. The greater or mass of the object being accelerated, the greater or amount of force need to accelerate to the object. Okay, the formula is F equal to ma. The equipment on this report is scale, set of weight balance, stopwatch, meter ruler and protector set. Okay, for the safety on the lab, please do not experiment without the lecturer supervisor. After finish experiment, please arrange equipment. The last one, never use lab equipment that you are not approved or trained by your lecturer to operate. Okay, that's all. Thank you.
Hi, Assalamualaikum. My name is Nur Faradiba binti Nordin. I'm from DEM 3A. My register number is 14 DEM 19F 1031. So I will tell the procedure. Firstly, set up the apparatus and material. Second, record a value of ml and distance of h, constant value. Then release a system from 0 to n and record to time when ml drop down. Repeat this procedure for different tests. Next step is repeat the procedure with a different value of ml. Last but not least, record the result at table below. So for the result, this is the table. Test 1. The height is 20 centimeter, but we need to convert to meter, so 0.2 meter. So for the mass gram is 100, 50, 20, 10, and 5. For the mass kilogram, 0.1, 0.05, 0.02, 0.01, and last 0.005. For the time, we have T1, T2, T3, and time average. So for T1, 0.97, 1.45, 1.13, 1.04, 1.45. For T2, 1.46, 1.21, 1.53, 1.28, 1.61. For time 3, 0.97, 0.91, 1.21, 1.29, and 1.36. For the time average is 1.13, 1.19, 1.29, 1.2, and 1.47. So for the acceleration is 0.18, 0.17, 0.16, 0.17, and last 0.14. For the acceleration, 0.16, 0.14, 0.12, 0.14, last 0.1. So for the table test 2, the height is 30 centimeter. When we convert is 0.3 meter. For the mass gram, 100, 50, 20, 10, and 5. So for the mass kilogram, 0.1, 0.05, 0.02, 0.01, and 0.005. For the time 1.05, 1.13, 0.72, 1.06, and 1.21. For the T2, 0.96, 0.88, 0.8, 1.06, and 1.21. For the T3, 1.13, 0.89, 0.97, 1.21, and 1.41. For the time average is 1.05, 0.97, 0.83, 1.11, and 1.28. T 0.29, 0.31, 0.36, 0.27, and 0.23. For the acceleration, 0.28, 0.32, 0.3, 0.43, 0.24, 0.18. Firstly, we need to convert gram to kilogram. To find the time average, first the formula is T1 plus T2 plus T3 divide 3. So you can get the time average. So for the test 1, 0.97 plus 1.46 plus 0.97 divide 3 equal is 1.13. Next, 1.45 plus 1.21 plus 0.91 divide to 3 equal 1.19. Then 1.13 plus 1.53 plus 1.21 divide to 3, the equal is 1.29. 1.04 plus 1.28 plus 1.29 divide 3 equal 1.2. Last, 1.45 plus 1.61 plus 1.36 divide 3, the equal is 1.47. Time average for test 2 is still use the same formula. So 1.05 plus 0.96 plus 1.13 divide 3, the equal 1.05. Next, 1.13 plus 0.88 plus 0.89 divide 3, so the equal is 0.97. Next, 0.72 plus 0.8 plus 0.97 divide 3, the equal is 0.83. Next, 1.06 plus 1.06 plus 1.21 divide 3, the equal 1.11. Last, 1. To find the velocity, the formula is height divided by time average. So for the test 1, 20 centimeter we need to convert to meter, so we get the 0.2 meter. Okay, 0.2 divide 1.13 equals 0.18. 0.2 divide 1.19, the equal is 0.17. 0.2 equal divide to 1.29, the equal is 0.16. 0.2 divide 1.2, the equal is 0.17. Last, 0.2 divide 1.47, the equal is 0.14. Velocity for test 1 is, the height is 30 centimeters, so when we convert is 0.3 meter. 0.3 divide 1.05, the equal is 0.29. 0.3 divide to 0.97, the equal 0.31. 0.3 divide by 0.83, the equal is 0.36. 0.3 divide 1.11, the equal is 0.27. And last, 0.3 divide 1.28, the equals is 0.23. To get the acceleration, velocity divide time. So for the test 1, 0.18 divide 0.13, the equals is 0.16. 0.17 equal 1.19, the equal is 0.14. 0.16 divide to 0.29, the equal is 0.12. 0.17 divide 1.2, the equal is 0.14. And lastly, 0.14 divide 1.47, the equal is 0.1. For test 2, acceleration, 0.29 divide 1.05 equal 0.28. 0.31 divide 0.97, the equal is 0.32. 0.36 divide 0.83, the equal is 0.43. 0.27 divide 1.11, the equal is 0.24. And lastly, 0.23 divide 1.28, the equal is 0.18.
So, discussion. From the result, we can easily see the relationship between position, velocity, acceleration, and force. From test 1, the graph, the graph moves slowly with a height of 0.2 meter. And because of this, the velocity is almost horizontal. Therefore, the time taken is longer than test 2. And test 2 is, where for the test 2, the graph decreases faster and the velocity is slightly lower as the height is 0.3 meter and the time taken is shorter than test 1. So in conclusion, we could conclude that the force is indeed a function of mass and acceleration, since two scenarios both supported it. And the Newton's second law of motion is true from the result of the experiment. We know how to use the equipment for experiment and know how to analyze the result from the measurement. Thank you.